Okay, so let's try that again. Okay, hopefully that still works and you're still seeing the screen. Um, Good news is for everybody who clearly cares about the inner workings of Yonatan's life, my passport renewal arrived this morning. It turns out that that's not enough time to get to Korea though. So thank you for hanging out with me virtually. I was thinking about what to talk about, and we were having some emails in advance of this. I was sort of with Simon and so forth about kind of who's in the room and what things kind of get talked about in the setting. And this comment came up that I'm one of the only people probably whose formal background is as a language person who then started playing with robots. And so I would maybe lean into that a little bit more heavily than usual and talk a little bit about sort of what that means. What does it mean to sort of have the richness of language, and where do I see the community right now? What are some kind of fun, open questions? And so to start off, let me just say, but like it's amazing and it's wonderful that we actually have this kind of setting, that we have everybody here that's interested in these topics, because it's felt like, I think the last like 8 years or so, up until like the last year, it was really hard to convince people like that this is a great place for our attention. And now that we can sort of access language via API, all of a sudden, like everyone wants to do language. The sort of bad news is that means that I don't think a lot of people have thought that deeply about what language actually is yet. And so that means that the great news is that we as a community can sort of try to address that by building a space where all of the expertise and the sort of richness of language and robotics get to interact with each other. So I'll talk about this a little bit more throughout the whole talk, but just to give sort of a simple analogy, I think that where we are right now is very exciting, but it's kind of akin to when language people would show up to a robotics set situation, be like, oh, I downloaded RL Bench, and so therefore I'm doing robotics. And then like a bunch of robotics people would be like, well, not really. Like there's kind of a gap between what you're describing and what the sort of real world is of deployment. And so there's a similar thing here that I want people to think about in terms of language complexity, which is that what we have right now are an amazing set of tools, but we're sort of just scratching the surface in terms of what it means to sort of interact with words versus their sort of richness of language. Okay, so like what is the richness of language? So the first thing I want to sort of put in people's heads, if they're not familiar with this, is that language is metaphor, language is abstraction. So when we talk about things in sort of happening, when we talk about sort of the acquisition of concepts, we can see this both in the history of linguistics and in our own developmental process of learning language. So I'm going to use a really simple example. When you're a little kid and someone says that we're going to walk forward, like we're going to walk down the sidewalk, what we learn is a physical understanding of that term. We learn that that means that like there's some spatial dimension, and to move forward means to sort of increment in that dimension. And then at some point you were taught that, well, forward is also something that you could apply to time. So we could pretend that time is a fourth dimension that's not a physical dimension, but you can sort of still experience, and this term still applies to it. And so what we did is we took that very literal understanding of spatial dimensions, and we transferred it, we abstracted it into this kind of thing that's not as tangible. And we continued to do that through our entire lives. So then at some point, someone tells you that they're going to move a project forward. And what they're doing there is they're making a metaphorical sort of abstracted reference to that physical understanding, except now it's about a project which is not really tangible. And forward is sort of like, well, what is our assessment of how this thing is going? And this just continues along as we introduce new and new words. So for instance, we're making progress. What does it mean to make progress? Well, the etymology of progress is actually the action of walking forward. So it is a physical analogy that we've sort of taken, and then we turn into things like social progress and so forth. So this is the progression, no pun intended. This is the process that we go through as we take something that's very concrete, and then through language, we introduce abstraction and metaphor. And so then we have a similar kind of sort of opportunity in terms of working with robots. So where we've historically done things like move forward as a very simple command, taking that very literal physical understanding of it, we're moving increasingly towards these kind of more underspecified kinds of requests. So this is one I just made up today, which is, can you make progress on packing the orders while I print the shipping labels? And it sounds really simple. It's the kind of thing that we would, use, the kind of language you would use with another person without thinking about anything. It wouldn't seem like a complex instruction. But if we then try to think about operationalizing that, so what's the implied task plan here? Sort of, what is the assumed knowledge? What are my affordances? What are your affordances? Are there certain places where it wouldn't make sense? So maybe I can't actually completely finish the packaging, but there's certain components of it that would be best. I definitely don't want to maybe seal it in a place where your shipping label might impact it, but that might mean that I need to not just take actions, but also ask for clarifications. So maybe the appropriate thing for me is to respond in language. There's all this other sort of complexity that we take for granted that we want our systems to be able to have. And the reason for that is because we don't, when we interpret language, we don't just take those words and sort of turn them into low-level actions. What we do is we understand them in this sort of notion of a social context and what's implied by them. And so I'll give one more slide sort of on that sort of high-level concept, which is that language is this sort of fundamentally social and pragmatic construction. So I really, really love this incredibly simple example of working with blocks in a sort of blocks world, where if I gave you something like this, I say, put an orange block to the right of green, you understand that green is the green block, you understand what right is, and I don't know, I could try doing this. I can maybe see hands if I zoom in on the camera here, but I could then ask you whether or not putting an orange block to the right of green implies that this is the correct interpretation. And I suspect that the answer in the room is no. If I was to say, is it this one? People would generally be happy with that. If it was this one, they would again say that's not quite right. If I said this one, it's not. And so there's this really, really great question here, which is, why is it that only one of these is correct when all of them are correct? And the reason for this is because of pragmatic context. So just because I have some training datum, some single instance in my training set, which says, oh yeah, here's a linguistic instruction, here's an image, or here's the spatial locations of all the objects in the scene, and here's what you should do, isn't actually that helpful. What I really need to understand is that if I wanted you to break symmetry, I would have told you to break it. This is pragmatics. It's that I gave you this very simple instruction because it was obvious to me that it would be obvious to you that there were symmetries in this space. And so therefore, I didn't need to mention them. You would understand where to put the block. And had I not intended for you to do that, I would have added an additional clause that specified something like immediately to the right of green, or a good distance to the right of green. But since I didn't do that, I didn't mean for that. And so this is kind of the really fun thing about what it means to sort of build towards increasingly rich language, is to think about these kinds of complexities. And so let me pop up a level here and just say, like, so then I like to ask this question, which is like, are we talking to robots when we're sort of doing all of these kinds of really cool research experiments, entirely my own included? This is not an attack on anybody, it's an attack on myself. And so then the questions become like, well, what do we mean by a robot? Do we mean task plans or APIs or motion plans? Who's the we here? Is it adults? Is it English speakers? Is it experts? What is talking? Are we actually instructing? Or as I've been alluding to, is it sort of this collaborative setting? Are we dealing with text or speech? What about all the sort of emotion and intonation that's present in the speech signal that wouldn't be present in the text? The social context in which this instruction is being given. And so most of my work, for example, falls into this narrow band. I'm assuming I have an adult English speaker who can provide a sort of basically self-contained within the context of the world instruction, which can be mapped to a task plan. And so I'm not, or I think most of us are not, thinking about sort of what does it mean to be a collaborative agent. That would mean that maybe there'd be some teaching involved, some working with people that are sort of maybe don't have a nice self-contained instruction to give you, and are taking sort of feedback from the environment, including about those person's actions, in order to sort of build up to real language. So this is kind of this maybe roadmap or set of questions that I would leave you with in terms of, well, where are we right now? And if you look at some of these papers that are coming out, which are incredibly awesome, and you're like, like everyone's already doing everything, it's like, actually, hold on, there's like a there's like a really, really big space of questions here. We have a really great opportunity for this community to grow a lot. And so for the remainder of this talk, which I realize I've given you already maybe too much time on just this high-level linguistic concept, I want to talk about sort of one axis of making things harder, which is not sort of increasing visual fidelity or degrees of freedom in our robots, but actually if we're going to move to sort of something that's rich in also the linguistic dimension, then what does it mean to have sort of theory of mind? What does it mean to have this sort of social understanding of language? So as you may be wondering at this point, is Yonatan really going to spend this entire talk telling everyone to take a linguistics class? Like I'm done with that aspect. But I wanted to just give people a flavor of like, what is the sort of richness of language that is assumed when we're talking with humans. Now, there's a lot of work that we need to do at a much lower level as well. So my collaborators would kill me if I didn't say, like, for example, we're trying to assist in this. So like we are running a challenge at NeurIPS this year on open vocabulary mobile manipulation. And so the idea is that you can train systems in simulation, you can then transfer them to, in this case, the stretch robot from Hello Robot. It's a collaboration with Hello Robot in order to sort of build up those basic core robotic functionality that we need for sort of, again, open vocabulary on a mobile manipulator, which is what we need in order to have those agents that really understand language that do more complex tasks. But popping back up to what sort of makes language really hard, I want to talk specifically about embodied dialogue and its role with theory of mind for a second. So if I have an agent in an environment, we're starting to see some people ask this question: how does the agent know when to ask a question? We then have to posit what is a useful question. So the simplest version is, if a system is confused, it simply says, help, please tell me what to do. But that's not how we interact. What we do when we ask a question is we try to think about what information you have about us and what information you have about the environment, and how to strategically extract the right piece of information from you so that we don't, like, I don't know, get you handing us a user manual. If we had a robot which was providing answers, so if we had, let's say, two autonomous agents that were having this interaction and teaching one another, then that means that that agent has to think about, well, what is it that you know, or what is it that your question implies that you may be confused about, which is not necessarily what I thought you'd be confused about. And so therefore, this is what the most sort of useful response might be to that. And then all of that boils down to eventually getting a language instruction that you're actually able to execute, which is kind of the band most of us are working in, is sort of just that last one. And so you have this kind of recursive theory of mind that becomes necessary, which is, in order to ask a question, I have to have a good calibrated uncertainty about my own actions. In order to ask a good question, I have to sort of understand, what uncertainties you might have, perhaps about me. Similarly, then for an answer, it becomes sort of this recursive thing. And so what we're doing in these settings is it's very akin to the world modeling that we tend to use for our agents, except that it's now an individualized world model. I'm not building an understanding of physics of the environment. I'm building a model of you and how you may or may not interact in the environment and your understanding of it. And so one place that we see this very concretely is in sort of language coordination. And so in these next couple of results, which I'll move through kind of quickly as punchlines, the idea behind all of them is that if you have an explicit model of the other person's actions or what you think they are or are not learning, that enables you to use language more effectively. So in this particular case, we say, here's a really simple environment. I want to do something, pick up a wine bottle and cool it and place it on the dining room table. And so then you have one simulated agent giving this instruction to another simulated agent, but it doesn't know when to interject, when to provide additional feedback. And so in this case, we have a very explicit model, which you're seeing sort of caricatured as a histogram on the side, of what we think the actions are that the second agent might take. So it says it's going to go to the cabinet. We think that makes sense. It might go to the fridge. It might go to the microwave. Stuff like this. We've conveyed the goal. Let's see what they do. If they arrive at the cabinet, it's closed. What do we, if they say they're going to open the cabinet, we think they're going to go to the fridge afterwards. Not a problem. They find a bottle of wine. They pick it up. What are they going to do next? They're going to go to the fridge, right? We told them they needed to cool it, right? That's the next step. And then they go to the microwave. And so we have this moment of violation where our model of what we thought that they were going to do doesn't agree with what they actually did. And so therefore we need to interject and give them a correction, in this case, to go and walk to the fridge, providing a kind of low-level correction. So if you want to build an agent that's able to do this, that's able to play this kind of game of, I think you're going to do this, oh wait, you violated my expectations, then you need to have an agent which has interacted with other agents. And so we end up with a chicken and egg problem, which is that if I need agents that can follow instructions, I need agents that can learn to give instructions, but giving instructions requires that I can take instructions and so forth. And so in this setting, what we do is we say, this is simplified in that it's in a simulator and it's a constrained semantics. So we'll take high-level task descriptions, like pick and place the wine bottle, and we'll break it down into sort of lower-level skills recursively. I think we only had 4 layers in this one. And then we'll train a population of agents where we sample skills. So we'll say, I'm going to train you to follow instructions, but you're going to learn how to do this high-level skill, that low-level skill, and so forth. And so then I will be able to do a meta-learning style approach for how to give instructions or how to know when to provide interjections, because I have this population of agents that all have different knowledge of the space. And so therefore, I have to be fast adapting to this diverse population. And the idea here is that I now have a way to sort of moderate, sort of penalize an agent that either has really sort of explicit instructions. So that would be someone that gives you too many low-level instructions. That means lots of interjections. That's going to give you a lot of penalty, but you're going to have high task success or points here, versus one that is sort of more parsimonious, tries to sort of avoid use of language that's not necessary. And we want sort of as a community to move up to that corner, sort of being able to very quickly adapt to understand what's implied by a misstep from one of the other agents, so that we can use that in order to produce sort of just the right amount of interjection. And the punchline from this is that learning needs a community, that language sort of only makes sense if we understand who we're talking to, which means that we have to be learning it in this context of modeling the other people. I try to look at the clock, so I will make sure that I don't go too much longer. The place that I think that we see this the most naturally in humans, and so then we've tried to port some of this over into simulation or into simulated agents, is in learning language in the first place. So you don't actually start off knowing language. So one of the very interesting / kind of weird things about the way that we're approaching this in robotics is that we're starting off with these really large language models that have this really strong language processing system, which is then being ported into task plans and so forth, which is not at all how you learned language. The way you learned language was through this, again, sort of theory of mind-based interaction with a caregiver. So here we have simplified this obviously, but let's say the child says square blue, and the parent hears that and says, oh, well, given the settings, there's only one thing that they could be referring to. And so I believe that my mental model aligns with their intention, and I'm going to give them a linguistic correction. Oh, that would be phrased a blue square. But that doesn't always work out. So here, if the child says an orange square, the parent or the caregiver has to now try to figure out, well, do I think that what's happening is that they don't know what orange is, and so, or how to say red, and so they're kind of using a color that's similar, or maybe it's more likely that what's going on is that they don't know the complex term rhombus, and so they're using square to overgeneralize to anything that has these sort of hard shapes. And so now we have this guess and this therefore disconnect between what is inside of the mental model of the learner, and so what they're trying to convey, versus the kind of correction that I'm giving. And so you can think about this in a slightly more naturalistic setting if you think about the way that we train our multimodal models right now, which is that I could just do it via captioning. I say, here's a bunch of images, here's a bunch of text, please learn all these correspondences. Or I could do this via a communicative game, where I say, like, a baseball player waits to the pitch, and then the learner is trying to guess which of these it thinks that corresponds to, and then we give sort of a signal if they got it correct. And so therefore, they're trying to find these correspondences via this interaction. And so what I'm showing here with these sort of faint lines, the blue line is a learner that has both a communicative goal, this gameplay, and is getting linguistic corrections for how to phrase things appropriately, versus the orange line, which is the most interesting comparison, is one which is trained via our traditional kind of captioning alignment style approach. So that's an agent that basically isn't good. It has to sort of go through the entire data set, learning all these linguistic visual correspondences in order to be able to actually be able to pick the correct answer in this game, versus, so that sort of go through the entire data set, versus one that is kind of learning on the fly and finding these features. And we look at things like also the fluency of what they learn. So do they produce fluent text as an output? And if you just learn from the communicative game, no, but if you sort of have this nice balance between the two, yes. And that balance, again, brings us back to this really tricky question, which is, if I'm now the instructor interacting with teaching language, am I confident enough to sort of act? Am I confident enough to tell them that I think my mental model of you is right, and so this is the correction? Do I think that they need help, or do I think that they're going to get it right anyway? And sort of this begs these questions of how rich should my model of the student be? Sort of how complex should I be trying to infer their intents and how and model their errors in order to do this? And this directly parallels with the first paper citation that I showed you was from CogSci. This directly parallels in simulation the kinds of questions that are explored in the cognitive science literature for how do you actually learn language as a human. And so the punchline here is that sort of teaching is interactive. That's the way that you get language, and that's what makes sense. And so I think if I'm on track time-wise, I'm going to close basically here with the following sort of conclusion, which is that we have these world models, but we also sort of need to model minds when we're dealing with language, because language is this fundamentally social construction. It's not set in a vacuum. We choose our words specifically based off of who we think is going to hear them, what they think can be inferred. And so where we are as a community right now is very exciting, because we're really exploring or just starting to scratch the surface on instruction giving. But then there's this kind of next step, which is how do you ask questions? And then once you're asking questions, how do you get to actual collaboration where you have these sort of rich understandings of one? So this is kind of my teaser for sort of like, if you're in the room and you're thinking about language, like language is actually super exciting. It's a huge topic. And so I think there's a lot for us to do as sort of robo language people. So I will close there. Thank you for listening.
Thank you. That was an awesome talk. So let's take some questions now. I think we have one microphone here, and we have another one floating around. Yep, back there. I'll actually go ahead and get one started real quick, because the thing you said at the very end is very interesting to me with theory of mind. I fully agree, but there's been an interesting, very recently, a lot of work in this area with language models, right? Where there was the paper put out, and you're like, oh, the large language models can actually solve theory of mind, these Sally-Ann tasks, right? And then there was the one right after that where they're like, oh, the trivial changes to them actually completely breaks it. So given the issue that the language models have of consistency internally and hallucinations, how do you think this is going to work with theory of mind? Like, do you think we're going to need new methods to handle this, or?
Yeah, so I think what's happening right now is awesome and fascinating. So I tend to try to answer these things through two different lenses. So if I was in a longer conversation, I would be like, here's my engineering hat. Here's how we should use large language models to do awesome stuff. But I think some other speakers are going to cover that. So right now I'm playing my sort of like weird cog-sci scientist hat. So there's really nice priors that are being learned there, but there's this real disconnect. So there's this great literature. I will answer your question, but I realize this is roundabout. There's some really nice results that are coming out of the language community where there's a disconnect between the types of information that language models can generalize from versus the kinds of information that humans can. So a human gets child-directed speech. It's very simple kind of language from their caregiver that they're able to then learn general linguistic structures from. And if you give that kind of data to a language model, it doesn't learn syntax, it doesn't learn all these kinds of basic things. It sort of really needs that adult language. And we see this similarly when it comes to things like mathematics, right? If I teach you how to do addition of 2-digit or 3-digit numbers, you can do a 10-digit number. It's not a problem because you've kind of learned this more general sort of representation than the specific surface form. And that's not true for the language model. Okay, so coming back to kind of the theory of mind stuff, what I'm positing is that that is another incarnation of this, where yeah, we're going to have basically totally fundamentally different approaches. Baby steps to that might mean that we have multiple language models. Maybe we have one which is a model which is being trying to capture your specific types of language, and then we're using that to sort of re-rank or something like this. But that basically a single model which is just trying to imitate or predict the next token is not going to be one that actually builds these kinds of personalized world models of your knowledge and then sort of develops alongside it. So I'm actually pretty excited about the idea that there's a bunch of models, but I also don't want to send us down this rabbit hole where, if you think about this from a straight computer science perspective, that every single person you meet, you have a new instance of a language model. That also feels wrong, right? So clearly we generalize between people. It's like, oh, well, they're talking to a college audience. You're talking to a conference, you're talking to whatever else. And so how do we get that kind of personalization while still sharing information is like a super interesting question. So that's an insanely roundabout answer to your question.
Hey, Anton Knuckle here.
I recognize you immediately.
Of course. Sleep deprived and everything. So what I was trying to figure out is, we're talking about all these interactive things that you want to learn with the robot, right? You're talking about communication, you're talking about like modeling somebody's implicit model and stuff like that. Sample complexity is a big issue, right? Like how do you collect that data? And like, it's one thing to say that your large language model can pretend dialogue for a while, right? But if you're making a learning system where a thing is learning on the fly, how the heck do you generalize to those kind of like,
Yeah, no, it's a great question. I actually removed some slides about the issues with data collection for dialogue because it sort of felt like another large topic. So the short answer is that we don't know how to do it. That data collection for dialogue is actually really, really hard because it's not clear what the definition of state should be. So I think when we tend to collect data, we tend to think like, we don't use this language that often anymore, but we're basically still treating it like it's an MDP, POMDP style problem where we can kind of define state and have this notion of what the next language instruction, something like this, is how it's going to affect that and what we should do with it. But since in this context, the state is entirely latent, and in the sense that it's in this person's mind, I realize POMDPs have this property. It's very hard to know what to write down in order to know like what it means to capture this. So I think that what's happening right now, at least as a first step, is that we're using these large language models as the generic person. So we say like, oh, well, it has common sense. And what does common sense mean? Well, here's the prototypical behavior, the prototypical response that you would expect. And that's totally reasonable. And so now the question, a very, very practical way to maybe try to make progress on this is, can we just use sort of individualized adapters that capture the types of preferences or actions that individuals take? So this person is, I got some signal from my interaction with them that they understood this or they didn't understand that. So can I use that feedback in order to learn something that's unique to them so that this moves forward? One of the things that we aren't doing right now as a community, not just robotics, but language in general, is we're not really doing personalization. We're not really letting these models sort of move with you. And so what that means is that it gets frustrating because you sort of thought that you taught the model something. You sort of thought you said, no, I'm vegetarian, but you have to say that every single time. And so it's not capturing that. And I think that gets more annoying when you're dealing with a physical assistant in your home than even when you're dealing with an Alexa or a Siri type situation. So I think that's like kind of our baby step. And there's a really interesting question again about how do you then do transfer. So the way I like to think about this is that if you imagine that you were doing sort of a Bayesian non-parametrics sort of approach where every individual is sampled from a base population, but that base population that is then sampled from another. And so you have this kind of hierarchy of sort of shared parameters and information that you want to allow you to generalize, but you also want to make sure that you're keeping individualization. So I don't know, but those are some thoughts on maybe some baby steps for how to start this. Yeah.
Okay, I think it's all we have time for questions. So
No problem.
please, thank you again.